All right, your last lesson in this unit is called Symmetry. In this section, guys will talk about three types of symmetry: line, point, and rotational. And we're going to add one piece of rotational. It's going to be called magnitude. We'll talk about that once we get to some examples. But for line symmetry, it's simply a figure has line symmetry if the figure can be mapped onto itself by reflection in a line. It says, think of a mirror image, right? It's like line symmetry, basically. If I look at the example, if you take a line and you fold the figure in half on that line, would it match up on the other side? So in this case, yes. Right? This triangle does have line symmetry. If I fold in half on that line, it does match up. So this figure does have line symmetry. Point symmetry. A figure has point symmetry if the figure is mapped onto itself by rotating the figure 180 degrees about the center point. In other words, it looks the same thing upside down. So if I take this end, here's my point right in the middle. If I rotate this thing 180 degrees, does it still look the same? Yes. If you flip it upside down, does it still look the same? Yes. Rotational symmetry. A figure has rotational symmetry if the figure is mapped onto itself by rotating the figure less than 360 degrees about a center point. So in other words, how many times can I rotate this to get it back, right? So if you check out the sun, yes, it has rotational symmetry for sure. But I want you to add what's called magnitude to rotational symmetry. To figure out the magnitude for rotational symmetry, you take how many times can you spin this to get it back to the original. So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8. You take 360, divide that by how many times you can turn it to get back to the original. And in this case, the magnitude for this little sun would be 360 divided by 8, which comes out to be 45 degrees, which means you can rotate this figure 45 degrees 8 times until you get it back to the original. All right, let's look at some examples here. It says determine if the figures have line, points, and or rotational symmetry. Check all that apply. If it has rotational symmetry, I want you to give me the magnitude as well. All right. Does this have line symmetry? Oh, you bet. We can draw a line here. For practice, this is putting all the lines of symmetry. You can do the corners as well. So yes, this has line symmetry, and this has 1, 2, 3, 4, 5, 6 lines of symmetry. 1, 2, 3, 4, 5, 6. Yep. Point symmetry. Does this guy look like the same thing upside down? You bet. Rotational. Can I rotate this thing and then make it look like the original still? And then it says, yes, I sure can. Now, let's do magnitude for this. Remember, it's 360 divided by how many times you can rotate this thing. I can rotate this octagon or a hexagon 1, 2, 3, 4, 5, 6 times. 360 divided by 6 is 60 degrees. So the magnitude for this rotational symmetry is 60 degrees. I can rotate this figure 6 times at 60 degrees before I get it back to the original. Number 2, line symmetry. Oh, you bet. I have 3 lines of symmetry on this triangle. Point. If I flip this triangle upside down, does it look the same? It does not. Rotational? Yes. So for the magnitude, I take 360. In this case, I can rotate it 1, 2, 3 times. So the magnitude for this rotation would be 120 degrees, which means I can rotate this triangle 3 times at 120 degrees to get it back to the original. Number 3, the parallelogram. Line symmetry? No. Many kids will try to draw diagonal lines, but the problem is the corners do not match up. This does not have line symmetry. Point symmetry, you bet. If I flip it upside down, or do I rotate it 180? Does it look the same still? Yep, still looks the same. Rotational symmetry, it does. So for the magnitude, you take 360. How many times can you rotate it before you get back to the original? Well, I can only rotate it twice. Once here, and then once back to the original. So the magnitude for this guy would be 180 degrees, which means I can rotate this figure 2 times at 180 degrees to get it back to the original. Number 4, this is a goose egg. There's no line, there's no point, there's no rotational. That's a none. Number 5, yes, we have line symmetry, and you can draw a bunch of lines in here. I'm just going to check the box. But it does not have point symmetry. If I rotate this 180 degrees, this does not look the same. The point of the star would be down here, does not look the same. Rotational, you bet. Magnitude, 360. You can rotate the star 1, 2, 3, 4, 5 times to get it back to the original. 360 divided by 5. Your magnitude for this rotation would be 72 degrees, which means you can rotate it 5 times at 72 degrees to get it back to the original. Number 6, line symmetry, no. Point symmetry, you bet. If I rotate this 180 degrees, it looks the same still. If it has point, it's automatically going to have rotational. So we take 360. And I can rotate it once, 2 times to get back to the original, which would mean my magnitude would be 180 degrees. Number 7, the capital A. This guy only has line symmetry. Upside down, nope. For rotational, you got to do a complete 360 to get it back to the original. That's why it does not have rotational. Number 8, the lightning bolt. Nothing. Nothing there at all. Back page. Okay. Number 9, this does not have line symmetry. You can't fold this in half anywhere. Point symmetry, you bet. If I rotate it, 180 still looks the same. And this is also going to have rotational. I can rotate this thing 4 times to get back to the original. So for the magnitude, 360 divided by 4, that comes out to be 90 degrees, which means you can rotate this thing 4 times at 90 degrees to get it back to the original. Number 10, the little hourglass looking guy. For sure line, you can draw a vertical line down that guy. Point symmetry, yep. If you flip it upside down, it still looks the same. And if it has points, it automatically has rotational. So for your magnitude, 360, I can rotate it 2 times, and that would come out to be 180 degrees. Number 11, the capital R, nothing. Number 12, this guy only has line symmetry. If you check out the point, this is a skinnier point than this point down here. So if I flip it upside down, it will not have point symmetry. If it doesn't have point, it's not going to have rotational. 13, this guy has line symmetry. I can draw 3 lines of symmetry throughout that guy. No point though. If I flip it upside down, it's not going to look the same. But this guy does have rotational. I can rotate this thing 3 times to get back to the original. So magnitude, 360 divided by 3, 120. 14, line symmetry. Nope. For sure, point symmetry. If I rotate it 180, it still looks the same. If it has point, it automatically has rotational. I can rotate this thing 2 times to get back to the original. So I take 360 divided by 2. Your magnitude is 180. 15, I can draw lots of lines of symmetry throughout the clover. It's also going to have point. If you flip it upside down, it still looks the same. If it has point, it automatically has rotational. I can turn this thing 1, 2, 3, 4 times. So magnitude, 360 divided by 4. That comes out to be 90 degrees. Number 16, the queen. No line symmetry. I cannot cut that in half anywhere. Point symmetry, you bet. Flip it upside down, rotate it 180, so it looks the same. If it has point, it automatically has rotational. You can turn this thing 2 times to get back to the original. So your magnitude, 360 divided by 2, 180. 17, that weird looking shape, nothing. 18, this guy only has line symmetry. Point, nope, not going to work. If I rotate it 180, this little outer piece would be looking over here, would not look the same. In rotational, you have to do a complete 360 to make it look like that. That's why it does not have rotational. 19, line, nope. For point, if I rotate it 180, does it still look like this? No, but it does have rotational. I can rotate this thing 1, 2, 3 times. So magnitude, 360 divided by 3, 120. Number 20, the snowflake. This guy has line. You can draw all kinds of lines throughout that thing. Point symmetry, if you rotate it 180, still looks the same. And it also has rotational if it has points. We can rotate this thing 1, 2, 3, 4, 5, and 6 times. So magnitude, 360 divided by 6. That comes out to be 60 degrees. And that is it for symmetry.